The expectation of M as F can be written as following. And we just mentioned the expectation of X bar square should be equal to mu X bar square plus variance of X bar, right? Okay? And in this case, because we only deal with X bar I, that's the ice machine, right? So let us put I here, okay? Put I here. Okay, and so X bar I should be mu I, and here Ni sigma I square. Okay? So this is what we have here. Also we have X bar G, right? X bar G should be the mean is the total population mean, right? And the variance sigma square over n. And remember this n is actually summation Ni. Okay? When you deal with this kind of problem, you have to have clear idea about the respective mean, respective variance. Okay? You have to be careful there. So in this case, we are dealing with expectation of X bar I square. So it will be mu I square, right? Plus Ni sigma I square. Okay? Okay. So we move this expectation inside. So what do we get? R minus 1 summation Ni times, okay, mu I square plus Ni sigma I square. Any questions? And then here, minus n times, okay, mu square plus n sigma square. Right? Because expectation of X bar I square is equal to mu I square plus sigma I square over Ni. And here, X bar G square of the expectation, we take expectation of that, we get mu square plus sigma square divided by n. Okay. Okay, so let's get further. So, can I erase this? Okay, you have to keep this as your reference, okay? Okay, so we have 1 over R minus 1 summation Ni mu I square plus. In this case, Ni cancel out, right? So you got summation sigma I square minus n times mu square minus sigma square. Okay, any questions? Remember, when we do ANOVA, we have one important assumption. Sigma 1 square is equal to sigma 2 square is equal to sigma r square is equal to sigma square, right? Okay, so what does that mean? That means this is I from 1 to r, right? So how many do we have? We have r sigma square. R sigma square minus sigma square plus summation Ni mu I square minus summation Ni mu square, right? Because in this case, n is equal to summation Ni, right? Okay, n is equal to summation Ni. And so you have R square minus, R sigma square minus sigma square, so you have R minus 1 sigma square, right? So what do you get? You get sigma squared plus 1 over r minus 1 summation ni mu I squared minus mu squared. Okay? And for this part, we can simplify further, and this will be left as your homework. Okay, you want to try this. Later on, you're going to find out this is equal to this. Okay, so this one, okay, the whole thing you're going to end up here, and it should be easy to prove it. Okay, so you want to do this as your homework. Okay, so what does that mean? We already know expectation of MSE will be equal to sigma squared, right? And expectation of MSF is actually equal to sigma squared plus a square, right? And this one is non-negative. When we say it is non-negative, it will be positive or 0, right? So this one will be greater than or equal to sigma squared. Okay? Greater than or equal to sigma squared. So what does that mean? That means, okay, when we have this, so I will erase this. So that means when we have F distribution that is equal to MSF over MSE. And as a matter of fact, the purpose is to test this. Test whether mu1 is equal to mu2 is equal to mu r, and H1 is H not true, right? So when we do this kind of test, we will expect if H naught is true, then F should be equal to 1, right? Okay? If H naught is not true, then F should be greater than 1. Okay? Because we have this kind of property, so when we do the test, it is a right tail test. A right tail test. Okay? A right tail test. So if that's what we said before. If F naught is greater than the F star, so what would you do? You're going to reject H naught. If F naught is less than F star, then you accept H naught. Okay? So basically, this is the basis of the ANOVA. Okay? The whole thing is the basis for ANOVA. And now we want to discuss one example here. Okay? We have to get one example so that after the formulas, you know something more concrete, that you know what's going on here, how to apply all these formulas. Okay, questions? Okay, so then this is what is left here, right? Okay, so this is the table. Whenever you do ANOVA, okay, any kind of question related to ANOVA, it will be more convenient for you to have this table. Okay, and so that you won't get mistake. Okay, and you try to fill in all the numbers. Okay, try to fill in all the numbers. Okay, now the example here, let us say we want to get some typists, okay? We want to get some people to do typing for us. And of course, we would like to know which one is more efficient, right? Or whether they are equally efficient or not. So we have to do some analysis. So we get 3 persons. We get 3 persons and we test their how many words they type each minute. Okay, so we got 3 people, 3 different people, and we have test, each one test okay. Okay, so we got 3 people, okay? For each person, we get a test, okay? Test 10 times, okay? Each person get test 10 times. Each time, this is the number of words they type each minute, okay? So for this person, the first test, for the first minute, he got 12 words. The second person, 10 words, 21, etc., right? Of course, from here, you know these guys are not efficient, right? Suppose you want to get a typist, each person has to, I think, at least type 60 words in 1 minute, right? And these guys are not very efficient. Okay, so when you get all these numbers, you have to try to get from here to here, okay? So let us first figure out, in any case, so you want to be very careful here. For the final, you have to know how to calculate mean, how to calculate variance. It is still required, okay, still required. Okay, of course you can get x bar 1, right? X bar, you know, in this case, actually got 10 tests, okay, each person got 10 tests. So it's 10 divided by 10, and it is 12 plus 10 plus etc. to 16, right? So how much is this? This, yes. Somehow there's no, what's going on? X bar 1 should be equal to 16. And then you have to get x bar 2, right? X bar 2 is, you want to remember, it is just coincidence, okay? We have 10 for each person. But somehow, in the final, these may not be equal, right? 7, 6, 8, whatever, okay? And here you have 17 plus 21 plus etc. plus 15. And this number is equal to 18. And x bar 3, okay, it is 21 plus 20 plus etc. plus 25 divided by 10. What do you get? You get 23. Of course, from this number, you can say, well, that should be different, right? Because the first one, the mean is 16, the second one, 18, and then this one is so much larger, right? It's 23. And then you have to get x bar g, okay? What is x bar g? Add the whole thing, right? All of them added together, divided by 30. Okay, then what do you get? So it is 10, etc. up to here, 25, right? And this one, it is equal to 19. Okay? When you get all these numbers, then the next step is try to fill in the information here. Okay? So what can you do here? Because you know there are 3 different persons, right? So that means there are 3 different machines. So what is the degrees of freedom here? df means degrees of freedom. So what is the degrees of freedom here? How much it should be here? You have 3 different persons, right? So it should be 2, right? It should be 2. Okay, so you filled in this number, it is equal to 2. And what about here? We are talking about the degrees of freedom for SSE, right? What should that be? How much is it? It should be 27, right? Because this one is equal to 30. You have 3 machines, right? 3 different persons. So this is 27. Okay? And what about here? You have 29, right? 29. So basically, even though for those formulas it's kind of complicated and you want to prove expectation MSE, expectation MSF, even though it's like very difficult, right? But somehow, in terms of application, you know the formula and you just plug in the numbers, it should be easy, okay? Okay, then we should find this one, right? Remember, this is the difference of the factors. So the example we have machines, right? We are looking across machines. We are looking at across persons, okay? So this one is actually equal to summation x bar I minus x bar g square, right? Okay? And this is I1 to R, J1 to Ni. Okay? So we have 3 x bar, right? X bar 1, x bar 2, and x bar 3. Okay? Okay. So the first one is x bar 1 minus x bar g. And remember, it is square, right? And then x bar 2 minus x bar g square. And plus x bar 3 minus x bar g square, right? Okay. So this is the first, because the summation is from I to R, right? So actually you should have 3 separate items, okay? And then for each separate item, you have to add them all up, right? From 1 to Ni. And in this case, what does that mean? Because we have 10 items here, 10 items here, also 10 items here. So how many times do you add this thing? You add this thing 10 times. So you have to multiply it by 10, right? Multiply it by 10. Multiply it by 10, okay? Okay, so what do you have? You have x bar 1 is equal to 16 minus x bar g, that's 19 square times 10, right? And the second one is 18 minus 19 square times 10 plus 23 minus 19 square times 10, okay? So if you have clear idea about the definition, the rest of it should be easy, okay? You just plug in the numbers, okay? Plug in the numbers, and of course you want to be very careful when you use your calculator. And how much it should be here? Let me see how much it should be here. It should be equal to 100 and no. It should be equal to 260. Okay? So you want to do this again. Okay? Or there are some other examples in the book, so you want to check that. So you already get this. This one is actually SSF, right? So now we can fill in this number. Okay, SSF is equal to 260, right? Okay? And degrees of freedom is equal to 2. So what about MSF? How much should that be? This one should be equal to 260 divided by 2, right? So it is 130. Okay, any questions so far? Okay, after we deal with this, then we should try to get this number, right? SSE, sum of square due to error, right? Sum of square due to error. Because in this case, really, we only need SSF, SSE, MSF, and MSE. Do we need this number? We don't. So you don't have to calculate this number. But sometimes the question gives you this number, right? Then the other numbers. So sometimes you have to get the information here from here, right? But in this case, we don't have to calculate this. Okay, in this case, we don't have to deal with it. Anyway, let us get to SSE. Let me use this part, okay? When we do SSE, actually we looking within the machines, right? So summation xij minus x bar I square. Okay? Of course, there's some easy way to deal with it. So remember, we say sx square is equal to 1 over n minus 1 summation xi minus x bar square, right? And if it is xi square, then we have 1 over mi minus 1 summation 1 to ni, okay, x bar xij minus x bar I square, okay? So in this case, how can we get that? Si square times ni minus 1, okay, equals j from 1 to ni xij minus x bar I square, right? Remember, we have discussed this before. We can simplify it to the following. Summation, okay, j from 1 to ni xij square minus ni x bar I square. So why do I put down something like this? Because sometimes if I give you the information on sample variance, if I give you information on sample variance, then you don't have to go through the step here. Okay, so let us say you want to calculate this part, right? Without the information of sample variance, then what would you do? Then you have to, okay, there are the whole thing here, right? So you have I from 1 to R, J from 1 to Ni. So you are looking at 3 machines. So the first part would be 12 minus, okay, 12 minus 16 square plus 10 minus 16 square plus up to 16 minus 16 square, right? But this is for the first machine only, okay? You have to do 3 machines, right? So let me erase this part. Okay? So this for the first machine, then the second machine, 17 minus, okay, this is x bar 2, right? This should be x bar 2, so it is here, 18 square plus the second one, 21, right? The second one, 21 minus 18 square plus 15 minus 18 square. So this is the difference for the first machine, the difference for the second machine. Okay, it is square of the sum. And then, the sum of the square. 21 minus 23 square and 20 minus 23 square. Because the first one is 21, the second one is 20, right? And then, etc. plus 25 minus 23 square. Of course, if you want to get a result from here, it is very tedious, right? Very tedious. And sometimes you may make a mistake when you put down all the numbers. So if I have information about sample variance, if I have information about sample variance in the final, it will be easy, right? It will be easy, okay? Because this one is exactly the same as here, right? So if you have information about sample variance, you should use that information instead of going through the tedious step here. But of course, in this question, do we have information about sample variance? We don't, okay? We don't have that. Okay, anyway. So the total here is equal to 412, okay, 412. So what does that mean? That means this number is equal to 412, right? And then we have MSE, right? You have to calculate MSE. So MSE, so this one is actually 130 is equal to 260 divided by 2, right? And then this number, what we get is 15.26. That is equal to 412 divided by 27. Okay? So after you fill in all these numbers, then the next step is to find out what is the critical value, okay, of the f. And then we compare the two values and to see what should be the result, okay, what should be our decision. Questions? Okay, let me erase this. Okay, so we know F is equal to MSF divided by MSE, right? And so this is equal to 130 divided by 15.26. Okay? So can anyone tell me what should be this number here? 130 divided by 15.26. Anyone get a number? .52, okay? 8.52. Now, this is the information from the sample, right? Of course, if we want to know whether this one is greater than or equal to or less than the critical value, then we have to find a critical value, right? So what should be the critical value here? And let us say alpha, that is the significant level, is 0.05, okay? So then F star, the critical value should be equal to F, okay, degrees of freedom, the first number should be 2, right? The first number should be 2 because it is here, okay? R minus 1. So anyway, this should be R minus 1 summation Ni minus R, alpha, right? And so that would be F2, Okay, the degrees of freedom should be 2 for the first one and 27 for the second one. Okay, and then of course you should look at the degrees of, the significant level should be 5%. And let us look at a book. So what should be the number here? You have to check table. Let me check what should be the table here. So you should look at page number 761. If you got a book, you should look at page 761. And if you look at the first one, right? The row there, okay, the row there, it is degrees of freedom for the numerator, right? The degrees of freedom for the numerator. If you look at the column, it is degrees of freedom for the denominator. So you should look at 2, right? You should look at the second column, okay? You should look at second column, okay? And then the 27th row, okay? The 27th row. If you look at the table, is 27 there? 27 is not there, right? But anyway, if you look at 25, okay? If you look at 25, how much is that? 3.39, right? That is for F225, okay? And let us look at another number. The next number is 30, right? So this one, let me put down this. Because the table doesn't have 227, right? But it has F225 is equal to 3.39, right? And F230, how much is that? It is equal to 3.32, okay? So what does that mean? That means this one should be greater than F227 because 227, degrees of freedom 227 should be between 3.39 and 3.32, right? And this number is 8.5. So this number, okay, what you get is actually F naught greater than F star. So what would be your decision? These three typists, the typing speed, is it the same or different? They have different typing speed, right? So that means we're going to reject H naught. So that means each person has different typing speed. Okay, the numbers they type within each minute, it will be different. Okay? So basically, this is the whole process of ANOVA. Any questions? So the most important things is that you should look at each question very carefully. And then you should have clear ideas about the definition of SSF, SSE, and SST. And then you have to know the degrees of freedom for each item, okay? Degrees of freedom for SSF, degrees of freedom for SSE, and degrees of freedom for SST. After you get all these numbers, then you get MSF and NFC, okay? From here, you get the observation from the sample, right? So this is the number you get. After you get this number, you have to compare this number with the critical value. So you have to find the critical value here. And this critical value has to do with the degrees of freedom. Don't get this number wrong, okay? Don't get any mistake on here. And then compare the observation with respect to the critical value. If it is higher than the critical value, what does that mean? you should reject H naught. Okay? If it is less than the critical value, then you're going to accept H naught. Okay? So basically, this is what's going on here. For next week, we will do some exercises in the book and also give you some more examples about ANOVA. And then we're going to discuss a little bit on regression. Okay, we will discuss something on regression, but regression will not be on the final. Okay, we won't have any questions on regression in our final. So let's take a break. See you next week. Say negatively related. Negatively related. What does that mean? That means one going up, the other going down, and one going down, the other going up. Okay? So basically you want to remember all these pictures. Okay? When you are confused, then try to put down this table to help you analyze the case. Okay? Any questions so far? Okay. So let us get to here. Because in this case we only see alpha, right? We only find out alpha. But there's no other things because we just mentioned beta, right? There's no beta here. Where to find the beta? Because beta is related to H1. Okay, beta related to H1. And how can we tell here? So let us say we have two pictures here. The same thing, right? This is the left-hand side critical value, and this is the right-hand side critical value. We know this is alpha over 2, and this is alpha over 2, and this is 1 minus alpha, right? And this number is 250, okay? So let us say when you try to take a sample out of it, and then you find out, actually, the sample value is, okay, let us say we use a different number is equal to 245, okay? Because the company, the manufacturer say it is 250, right? But actually you find out it is 245. So you may be suspicious, okay? You doubt whether the company get the right number, okay? Whether the claim is true or not. But really you find out it is 245. So in this case, the company believes that it is 250, but what do you believe? You believe that somehow it should be 245. So when we take this information into account, so this would be H naught. So when you deal with H naught, then you consider H naught as true. But when you deal with H1, okay, then you consider this is true, okay? So let us draw another picture here. Okay? And this is 245. And this is the right-hand side critical value here. And this is the same thing, left-hand side critical value here. Okay? So when you deal with this case, okay, this is 1 minus alpha, right? Okay? This is when you take action 1, okay? Action 1 means you believe in H1. But in this region, you believe you take action not, okay? And what's this? You believe in H not, okay? And here, you take action 1. You believe in H1, okay? So then, what should be this part here? Okay, what should be this part here? Okay, when H naught is true and also you believe H naught is true, then it is 1 minus alpha, right? Okay, but now we are dealing with the second hypothesis. We suppose this is true. So if this is true, okay, and you take this action, if this is true and you take this action, what should that be? It should be beta, okay? So here, H naught is true, and you take action to believe H naught. So what you get? You get 1 minus alpha, right? But now you believe H naught is not true. So that means H1 is true. H1 is true, and you take action A naught. What does that mean? That's wrong. Type 2 error. Okay, so in this region, what is that? That's type 2 error. And what is this region? This area, let us say, it is A, and this area, let us say, it is B. So the probability of A plus probability of B, what should that be? That should be equal to 1 minus beta. Okay? Okay. And then, look at this. If you increase the confidence interval, okay? If you increase the confidence interval, that means this one will move to the right and this one will move to the left. So alpha actually will decrease, okay? If you increase 1 minus alpha, if you increase 1 minus alpha, that means alpha is going down. If alpha is going down, what does that mean? That means beta will go up, right? Because the direction is the same, right? If these two values moves out, then alpha goes down. If this area moves out, then this area goes up, right? Okay? So from this diagram, you know, alpha goes up, then beta goes down, and alpha goes down, beta goes up. Okay? So basically, that's the situation there. Of course, in terms of hypothesis, there are several issues here. Okay? Let's use one example, medicine. And of course, when we talk about medicine, we want to believe that that's effective, right? Usually, the company will say, my medicine is effective to cure some kind of disease, okay? Of course, whether that's true or not, that's a question, right? We have to test it. But generally, if you are the company, you want to say, my medicine is very effective in curing certain kind of disease. But what about if you are the administration, say FDA? What is FDA? That's the Food and Drug Administration. Administration. In terms of type 1, what is that be? What should that be? That is, okay? So generally, if you develop a medicine, okay, then you have to apply for patent, apply for approval to sell to people. So in this case, then you have two questions, right? One, whether it is true or not, okay? Then whether you want to take it or not. So generally, for the pharmaceuticals, for the pharmaceuticals, they have to test, okay? If they want to develop certain kind of medicine, they have to do first animal test, okay? And when the animal test is successful, then they do the human test, okay? So generally, there is a procedure that they have to follow. But now let us say we are concerned about whether it's true or not, okay? So for this kind of medicine, H naught, what would they say? They say it is effective, okay? The company say it is effective, okay? And H1, of course, that's not effective, right? And the same thing here. You have 1 minus alpha, and alpha, you have beta, and 1 minus beta, okay? So now we have two persons. So let us say you are the pharmaceuticals, okay? So you are the company, okay? And you are the government. You are the government. So what would you do in this case? So we say when you do hypothesis test, after you set up the hypothesis, then you have to determine the significant level, right? We say you have to determine the significant level. Okay? You have to determine a significant level. In terms of the company, okay, in terms of the company, what would you say? In terms of the government, what would you say? In terms of the significant level. And what means significant level? Significant level is when the medicine is actually not effective, but what do you say? You say it is effective, right? So this is A1 is true, H1 is true, right? H1 is true. But you say H naught is true, right? So this is A1. What does A1 mean? Alpha is type 1 error, right? And what is error? This error is, as a matter of fact, the medicine cannot cure any disease, right? The medicine cannot cure any disease, but what do you say? You say it can cure a disease, okay? So then when you are the company, of course, because if the patent is successful, okay, the most important thing is that if the government does not give you the patent, you cannot sell the medicine, right? If the government inspect it and say, sorry, it's not effective, okay, then in that case, what is going to happen? They cannot sell the drug, okay? And the drug means revenue to the company. So of course, the company will do whatever they can to get approval, right? So the intention is to get approval and then to get revenue, right? What happened to the government? The government wants to prevent a lot of bad drugs, okay? Some drugs, actually, they cannot cure any disease, but some people say, you know, this drug can cure liver disease, can cure influenza, can cure a lot of disease, but actually it doesn't. So government has a different perspective. The company focuses on money. The government focuses on the welfare, the health of the people, right? So they have different focus. So these two persons, okay, when they are dealing with the same issue, okay, they would have different kind of attitude, okay? They have different kind of attitude. Let us take a break. We'll continue next hour.